quite short. We have 5 tools, meaning that we have 5 presentations, 10-minute time slots. We will strictly try to keep to that time slot and we'll signal for 2-minute deadline basically. I will allow for 1 single question for each tool, which will be assigned on first come, first serve principle. Some questions should be very general to highlight some of the features of the tool. So that's a teaser for people to go out and continue discussion at the tools until we go to the social event. Okay, so first presentation is by Christian Kneip from University of Tübingen, and the stage is yours.
Okay. Hello, my name is Christian Kneip.
It's okay, Kneip, oh sorry.
I'm an employee of Science and Computing AG and a former student at the University of Tübingen. Science and Computing is an IT service provider, mostly for the automotive sector. In my case, I'm working for Daimler and support and administrate the life cycle of clusters. So, and I'm going to show you, as it's written down, an open source-based framework for InfiniBand monitoring. So, I would like to give you a brief background about InfiniBand for those of you who did not know about it. It's a interconnect for clusters, for high-performance clusters. And if you look at the top 500 of the most powerful supercomputer clusters in the world, you will see that most of the interconnects are InfiniBand based. It's very expensive. That's why you don't have it in your Celeron, or you don't have it if you don't need it. It's point-to-point, bidirectional. So you have switches and you have network channel adapters and cables. The protocol is completely implemented in hardware. So you have an API on the driver that says, okay, I want to send this data from here to there, and the rest is done in hardware. So that's why it's very low latency in the nanoseconds, and it's given high bandwidth. So the actual standard is QDR, it's 40 gigabits per second, and the next one, which will be deployed this year, is FDR, it's 56 gigabits per second. You have one entity in the whole network which does network administration, which gives addresses, like IP addresses in TCP/IP, and does the network routing calculation and deploys the routing information to every switch. So every switch is very dumb, so to speak. It does only have a table which is destination and the local port. So if there comes a package which says, okay, I want to reach this destination, then it looks what port should I use to route it, and then it is gone. So no big workload for the switch. And it works on copper and fiber, so for small destinations we use copper and fiber for the destinations. InfiniBand, so the motivation is that normally InfiniBand just works. It's, as I said, very expensive, and therefore it's very, it works good normally. And if you have small networks, you plug it in and the whole setup, the whole configuration is done initially. That you don't have to do anything, so normally you just use it. But if you have problems, maybe a link is broken or a cable has troubles or a port has troubles, it's hard to debug where the problem really is. Is it the link, is it the port, is it the application? Because you have a rich toolbox, a lot of tools you can fire up and look at performance counters or look at topology. But you have to figure out the whole network to say that's a performance problem of the cable or anything. So that's why it's hard to debug, and you have to have a basic or a good knowledge of the treatment to debug the problem. Further on, the IP topology is not that intuitive, because if you have bigger switches, the switches are networks in a network. So a big switch has modules which which are basically switches within the big switch, and therefore, and this is presented by the topology. So if you look at the topology, you will see lots of switches, but you can't map it to the real hardware you have in your rack, or you can, but you have to know about it, and it's not intuitive for normal Ethernet guys who look at the InfiniBand like it's Ethernet. So. And the traffic flow, as I said, is hard to trace. You can't say this traffic on the switch comes from this source and goes to the destination, because it's all hardware. You can't dig in the routing or the traffic information. So there's a need for an intuitive monitoring tool, and that's what I have done in my thesis last year, and the 2.0 version is represented by the paper here. That's the architecture. So we have a couple of modules, like the input, the topology is given by the toolbox. There's a command which gives you a text file with the topology information, and this is what I parse with the first left discover tool for the topology. And the performance counters are collected by the entity, which makes all the routing calculations, and it has a plug-in architecture that you can probe all ports in the network to give you the performance information. And this is done every couple of seconds, and this information about the performance of every port is written into a database. Then we calculate the port utilization and traffic share, as you will see in the last slide. And the output, or all the information, is shown in maps and graphs about the performance. This is also shown on the last slide. As I said, it's very expensive, so you don't have the experimental setup in your room. So you have a need for a simulation of InfiniBand, and the good thing, or lucky me, there is an IBSIM called simulator for InfiniBand. You can give him a topology, and it will simulate the topology. And I have written a small GUI for it, so you can unplug the virtual nodes and unplug switches, and all the other nodes will be gone. And if you click it again, it's again in your topology. And what this IBSIM is doing is it simulates the InfiniBand network card and all the topology connected to it. Yeah, and simulation is one part, but it has some drawbacks. You can't simulate performance data, and you can simulate that the link is failing. It's just a node that you can get out of the topology. So we have the need for to show the whole monitoring tool. We have a need for hardware, so we brought a small rack with 8 servers and 2 InfiniBand switches, and this is what you can hear outside. Yeah, it shows the performance measurements. So the scenarios I will skip, and we will show it after this presentation, and then you can see it there. A small glance of the tool. It's there on the left upper side. You see the topology with the topology information. The EMVs are servers, and the 2 nodes in the middle are switches, as you can imagine. And the color of the switches indicates how local the traffic is. If all the 3 nodes on the bottom only are connected, or only firing data to each other, then this link will not be utilized, because all the traffic is still on the switch. So you don't have trouble on the uplink side, and if all the traffic goes up to another node here on the other switch, the link here in the middle should be very powerful to connect all the data and use the full bandwidth. So if the switch is red, then the traffic should be global. So the traffic here is very red, so the traffic goes up to the other switch and then is distributed to the other nodes.
40 seconds.
I think I'm done. Okay. Any question?
Yes.